Hello everyone, I am Lata Rani, Assistant Professor of Mathematics. Today I am going to discuss about the topic exponential series. It is there in the syllabus of Real Analysis and Algebra paper of the 5th semester BSc Mathematics. In the previous session you have learned about the binomial series and its problems. Today let us understand the definition and some examples on the exponential series. First, definition of exponential series is the series summation n is equal to 0 to infinity 1 over n factorial is equal to 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus so on up to infinity is called an exponential series, and its sum is denoted by e, where e is an irrational number called exponential number. Here we have some exponential theorem. By exponential theorem asserts that e to the power of x is equal to 1 plus x by 1 factorial plus x square divided by 2 factorial plus x cube by 3 factorial plus so on, which can be expressed in terms of summation n is equal to 0 to infinity x to the power of n over n factorial. Call it as equation number 1. Similarly, replace x by minus x, we get the equation e to the power of minus x is equal to 1 minus x by 1 factorial plus x square by 2 factorial minus x cube by 3 factorial so on. That is summation n is equal to 0 to infinity minus x to the power of n divided by n factorial. Call it as this as a equation number 2. Now adding equation 1 and equation 2, we get the formula e to the power of x plus e to the power of minus x is divided by 2 is equal to 1 plus x square by 2 factorial plus x to the power of 4 by 4 factorial plus so on. This can be expressed in terms of summation form n is equal to 0 to infinity x to the power of 2n divided by 2n factorial. Similarly, subtract 1 and 2, we get the another equation e to the power of x minus e to the power of minus x divided by 2 is equal to x by 1 factorial plus x cube by 3 factorial plus x to the power of 5 by 5 factorial so on. That is summation n is equal to 0 to infinity x to the power of 2n minus 1 divided by 2n minus 1 factorial. Now put x is equal to 1 in the above equations. First put x is equal to 1. Equation 1 becomes like that. E is equal to 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial, which can be expressed in terms of summation n is equal to 0 to infinity 1 by n factorial. And put x is equal to 1 in equation 2, we get e to the power of minus 1 is equal to summation n is equal to 0 to infinity minus 1 to the power of n divided by n factorial. Similarly, put x is equal to 1 in equation 2, we get e to the power of 1 plus e to the power of minus 1 divided by 2 is equal to 1 plus 1 by 2 factorial plus 1 by 4 factorial plus so on, which is equal to summation n is equal to 0 to infinity 1 over 2n factorial. Here put x is equal to 1 in equation number 4, we get this equation e power 1 minus e power minus 1 divided by 2 is equal to summation n is equal to 0 to infinity 1 over 2n minus 1 factorial. Now let us discuss about some problems by using the exponential theorems. Let us consider problem sum to infinity the series 1 square by 1 factorial plus 2 square by 2 factorial plus 3 square by 3 factorial plus so on. First we write the nth term for numerator and denominator. sum to n terms is equal to summation n is equal to 1 to infinity. The nth term of numerator is n square divided by the n number of denominator is n factorial. The numerator can be rearranged like that, n square minus n plus n for the problem solving. Then take the common factor in n square minus n, we get n into n minus 1 plus n divided by n factorial. Split the summation, we get summation n is equal to 1 to infinity n into n minus 1 divided by n factorial plus summation n is equal to 1 to infinity n by n factorial. See here, n factorial can be written as n into n minus 1 into n minus 2 factorial. N into n minus 1 will be get cancelled. We get first function as summation n is equal to 1 to infinity 1 by n minus 2 factorial. Similarly, same procedure will be applied for this function also. Summation n is equal to 1 to infinity. Here n factorial can be written as n into n minus 1 factorial. N get cancelled. We get 1 over n minus 1 factorial. Now expand the summation. N is equal to 1 on both sides. We get n 1 by 0 factorial plus 1 by 1 factorial plus 1 by 2 factorial plus so on. Plus similarly, here also expand the summation. We get 1 by 0 factorial plus 1 by 1 factorial plus 1 by 2 factorial. 1 by 0 factorial plus 1 by 1 factorial plus 1 by 2 factorial is nothing but the e. Therefore, we get the answer is e plus e is equal to 2e. Now let us go to the another example. Sum to infinity of the series n is equal to 1 to infinity 5n plus 1 divided by 2n plus 1 factorial. Sum to n terms is equal to n is equal to 1 to infinity 5n plus 1 divided by 2n plus 1 factorial. Now this can be written as summation n is equal to 1 to infinity 5n divided by 2n plus 1 factorial plus 1 over 2n plus 1 factorial. The first term can be written as 5n divided by 2n plus 1 factorial can be written like that, 5 by 2 times 2n plus 1 minus 1. Now solve this one, we get like that 5 by 2 2n plus 1 minus 5 by 2 plus 1 is nothing but 3 by 2 into 1 over 2n plus 1 factorial. Simplify, we get 5 by 2 n is equal to 1 to infinity 1 over 2n factorial minus 3 by 2 summation n is equal to 1 to infinity 1 over 2n plus 1 factorial. Now we expand the summation, we get like that 5 by 2 times, when we put n is equal to 1 we get 1 by 2 factorial plus n is equal to 2 we get 1 by 4 factorial plus 1 by 6 factorial plus so on. Similarly minus 3 by 2, here 2n plus 1 factorial is there, therefore 1 over 3 factorial plus 1 over 5 factorial plus 1 over 7 factorial so on. We know the formula 1 plus 1 by 2 factorial plus 1 by 4 factorial plus so on is equal to e plus e to the power of minus 1 by 2. Here the summation is starting from 1 by 2 factorial, therefore this can be written as e plus e to the power of minus 1 divided by 2 minus 1. Simplify, we get the solution 1 by 2 times e plus 4e to the power of minus 1 minus 2. Now we goes to the another example. Sum to infinity 1 over 1 factorial plus 1 square plus 2 square divided by 2 factorial plus 1 square plus 2 square plus 3 square divided by 3 factorial plus so on 1 square plus 2 square plus 3 square plus up to n square divided by n factorial. Sum to n terms is equal to summation n is equal to 1 to infinity. We take the sum to n terms as this function 1 square plus 2 square plus 3 square plus so on plus n square divided by n factorial. We know the formula for the numerator. What is the formula? The formula is n into n plus 1 into 2n plus 1 divided by 6. By using this formula, S can be written as summation n is equal to 1 to infinity n into n plus 1 2n plus 1 divided by 6n factorial. Here 1 by 6 is in a constant. Take outside from the summation. We get like that. Summation n is equal to 1 to infinity. Here numerator is a we have to simplify the numerator. We get like that 2n cube plus 3n square plus n divided by n factorial. Numerator is of degree cube. Therefore, we write 2n cube plus 3n square plus n can be written as a0 plus a1n plus a2 n into n minus 1 plus a3 n into n minus 1 into n minus 2 because of the power is in a 3. Now, equating the coefficient of the powers, different form of powers of n, then we get n cube coefficient is in a 2. Here n cube for coefficient is in a a3. Therefore, we get a3 is in a 2. Then comparing n square coefficient, we get a2 value. Then comparing the n coefficient, we get a1 value. And comparing the constant on both sides, we get a0 value. Here we get a0 is equal to 0, a1 is equal to 6, a2 is equal to 9 and a3 is equal to 2. Substitute these values in the 2n cube plus 3n square plus n equation. We get like that 2n into n minus 1 n minus 2 plus 9n into n minus 1 plus 6n plus 0 divided by n factorial. After simplification, we get like that 1 by 6 times summation of n is equal to 1 to infinity 2 divided by n minus 3 factorial plus 9 divided by n minus 2 factorial plus 6 divided by n minus 1 factorial. This summation is applicable for all these 3 terms. Now we expand the summation. For the first term, we get 1 by 0 factorial plus 1 by 1 factorial plus 1 by 2 factorial plus so on plus 9 into, for the second one we get 1 by 0 factorial plus 1 by 1 factorial plus 1 by 2 factorial and so on plus 6 times 1 by 0 factorial plus 1 by 1 factorial plus 1 by 2 factorial plus so on. We know the value of 1 plus 1 by 1 factorial plus 1 by 2 factorial as e. Therefore, we get the answer 1 by 6 into 2 times e plus 9 into e plus 6 into e. Simplify, we get 17e divided by 6. Students, in this session, we have learned exponential series concept and also solved some examples. By using these concepts, we can also solve these exercise problems. Thank you.